Welcome to an introduction to confidence intervals. Suppose you are trying to determine the mean or average rent of a two-bedroom apartment in your city. You might look online, write down several rents listed, and find the average. You would have obtained a point estimate of the true mean. For example, you might have found an average rent of $1,200 per month. We often use sample data to make generalizations of an unknown population. This part of statistics is called inferential statistics. The sample data help us to make an estimate of a population parameter. We realize that the point estimate is most likely not the exact value of the population parameter, but close to it to be useful. After calculating point estimates, we construct interval estimates called confidence intervals. So for example, for the rent, the interval estimate might be from $1,000 to $1,400 per month. If you worked in a marketing department of an entertainment company, you might be interested in the mean number of songs a consumer downloads a month from iTunes. If so, you could conduct a survey and calculate the sample mean, x bar, and the sample standard deviation, s. You would use x bar to estimate the population mean and s to estimate the population standard deviation. The sample mean x bar is the point estimate of the population mean mu. The sample standard deviation s is the point estimate for the population standard deviation sigma. Each x bar and s is called a statistic. A confidence interval is another type of estimate, but instead of being just one number, it is an interval of numbers. It provides a range of reasonable values in which we expect the population parameter to fall. There is no guarantee that a given confidence interval does capture the parameter, but there is a predictable probability of success. Suppose for the iTunes example, we do not know the population mean mu, but we do know the population standard deviation sigma is equal to 1, and our sample size is 100. Then by the central limit theorem, the standard deviation for the sample mean is equal to the standard deviation of the population divided by the square root of the sample size, which is equal to 1 divided by the square root of 100, which equals 1/10 or 0.1. The empirical rule, which applies to bell-shaped distributions, says that in approximately 95% of the samples, the sample mean x bar will be within 2 standard deviations of the population mean mu. For the iTunes example, 2 standard deviations is equal to 2 times 0.1 or 0.2. The sample mean x bar is likely to be within 0.2 units of mu. In other words, mu is between x bar minus 0.2 and x bar plus 0.2 in 95% of all of the samples. Meaning the 95% confidence interval is from x bar minus 0.2 to x bar plus 0.2. Again, for the iTunes example, suppose that a sample produced a sample mean of x bar equals 2, then the 95% confidence interval for the unknown population mean mu is between 2 minus 0.2 and 2 plus 0.2, which means the 95% confidence interval is 1.8 to 2.2. We say that we are 95% confident that the unknown population mean number of songs downloaded from iTunes per month is between 1.8 and 2.2. The 95% confidence interval implies two possibilities. Either the interval from 1.8 to 2.2 contains the true mean mu, or our sample produced an x bar that is not within 0.2 units of the true mean mu. The second possibility happens for only 5% of all of the samples. 100% minus 95%. Remember that a confidence interval is created for an unknown population parameter like the population mean mu. Confidence intervals for some parameters have the following form: the point estimate minus the margin of error, comma, the point estimate plus the margin of error. The margin of error depends on the confidence level or percentage of confidence and the standard error of the mean. When you read newspapers and journals, some reports will use the phrase margin of error. Other reports will not use that phrase, but include a confidence interval as the point estimate plus or minus the margin of error. These are two ways of expressing the same concept. We will begin to calculate confidence intervals in the next lesson. I hope you found this helpful.